So here, how do we do monitoring? We use mainly Prometheus to monitor our stuff. This is what the Prometheus console looks like. How does it work? It scrapes metrics off of applications that are deployed on your cluster. For example, let's say we have this one application, it has this route. This is Jupyter Hub. You can use this to create your own notebook servers. Now, what Prometheus does is it goes to the application URL and has a specific metrics endpoint. It will go scrape these metrics from the application. And once it scrapes these metrics, it will go store them here in a timestamp database. It's a time series. So what we can do is we can essentially plot what containers were this metric will show us what containers were up in the last hour or what containers were down. That's basically what Prometheus is. It also does alerts on. So we this is the OpenShift monitoring Prometheus that we are saying right now. It has a bunch of alerts already defined. For example, uh, cloud credential operator target namespace missing. It's missing a specific namespace. If it's missing a specific namespace, it would create an alert. What happens if there's an alert? Uh, we have set up a GitHub alert receiver, which transfers all of these alerts to our GitHub repository here, operate for /alerts. We get all of our alerts here, and we're planning to add more features to this. For example, if an alert is created, uh, specific label should be added to that alert, and specific people who manage that service should be tagged in that issue. So uh, people who would be able, people responsible for the service will be able to fix it sooner. Otherwise, you can see what can happen. We have like 21,000 closed alerts, and usually it's hard to focus on or like sort through all of these alerts. So it's easier. It would be easier for us if we were able to add specific people to each issue. What happens when there's an alert and an issue is created? Uh, let's say there was an alert and we create an issue from it. We create an incident. Uh, this is an example incident that occurred. This is all real. How do we manage this incident? We check what the issues are. We post all the logs in here, and we go through the whole process of fixing that issue and see so it's visible for everybody to see. This is one example where Tom tries fixing something, and in the end, we were able to fix it and we close the issue. Most of the communication occurs open in this issue. We also have a Slack channel we use, but like we try to put everything related to the issue or the incident in here, so it's documented and can be used later if some similar issue reoccurs. And how do we set up these alerts? So let's say we have a service deployed, like I said, Jupyter, right? So what we can do is we can set up these alerting rules, which says if this metric is absent or is not up for more than 10 minutes, create an alert and send it to the alert receiver. The alert receiver I'm talking about here is specific GitHub alert receiver. Prometheus comes with a side application called Alert Manager. What you can do is once you create alerts with it, you can uh, push them to different uh, outputs. One of the outputs that we're using is a GitHub alert receiver. This GitHub alert receiver, it processes these alerts and pushes them to the alerts repository that we have here that I showed before here. So these are just a bunch of open alerts from our zero cluster, which is down at the moment. And what happens if the alert is resolved? For example, sometimes it might happen is a service went down for 15 minutes, but then it came back up. The GitHub alert receiver will know that the alert is no longer firing, and it will close the issue. And we also do logging. Let's see here. So documentation for this is available on our Operate First website. For Prometheus, first we were deploying our own Prometheus instances using the Prometheus operator, but now we are slowly moving to using a user workload monitoring, which comes with OpenShift, and this will make our lives easier because it will keep all our metrics with OpenShift. And now we come to logging. For logging, we deploy Loki. What Loki does is it stores all of these. Loki is similar to Prometheus, but instead of a pull model, it's uses a push model. What that means is instead of an application posting their logs like this, uh, an application or a s- a sidecar needs to push all of these logs as JSONs to Loki, and then Loki stores all of these logs. And it gives you an interface to interact with Loki. You can query them, and you you can set up alerts with Loki metrics as well. Loki also includes how to. Loki is also a solution for how to store logs for long term. So we don't need to worry about how it will manage logs for long term. Unlike Prometheus, for Prometheus, what we need to figure out is, or we have a solution for it, how we store metrics for long term storage. Our Prometheus instances, they store metrics for about a week or two, but after that they are discarded. And some of these metrics we want them to stay for a longer time. So what we do is we deploy Thanos, and what Thanos does is it has some object storage attached to it in the backend, and it collects metrics from Prometheus. More like Prometheus pushes all of its metrics to Thanos using remote write, and Thanos collects them, compacts them, and optimizes them to be queried later. So Thanos has a bunch of microservices within itself, which do these individual tasks. Like there's Thanos compact, which will compact the metrics. There's Thanos store, which will store the metric to object storage, for example S3. There's Thanos query, which will query metrics from the object storage. There are a couple more microservices that I cannot remember, but they essentially cache metrics so they can be queried faster. And there's one more which downsamples these metrics. So essentially, we have the same metrics, but they are downsampled to different resolutions. For example, you can see here in our Operate First, this is what we had the resolution set as. The raw metrics, they were available to be queried for 7 days, and they were downsampled to one metric value for 5 minutes for the past 30 days, and one metric value for 1 hour for indefinite amount of time. So you would be able to query one metric value per hour for forever essentially. Uh, all metrics that are in available in Prometheus should be available in Thanos, since how we have it set up is Prometheus remote writes all the metrics available in it to the Thanos instances. Yep, that's about it. Let me show you the interface for Alert Manager, which manages the alert, and and how where OpenShift monitoring is deployed. I'll just This is OpenShift monitoring. You can see it's you can see there are three different pods for just alert manager, so it's scaled pretty well. It has, maybe you cannot see this. Let me zoom in. It has cube state metrics, which exposes metrics for Kubernetes. These are Kubernetes state metrics, so these are available by default in OpenShift monitoring. And we store all of these metrics to Thanos for long-term storage.
And
That is about it for monitoring.
this is what comes with OpenShift. So
Yeah.
all clusters that we have this, which allows us to then. You want to talk about the aggregation that we're working on right now, or?
Oh yeah. So we're trying to aggregate all the metrics from different clusters. For example, let me find the rig cluster. I think I would set up for the rig cluster. So by default, if I query for a metric here, right? Doesn't have any specific label that separates it for different clusters, right? So what we want to do is we want to be able to differentiate between metrics from different clusters. How we are doing is when it remote writes these metrics, there's a separate label that's to be added to these metrics. Let me show an example. So hopefully we will be able to see it here. Yes. So for example, this is the rig cluster which is deployed in the EMEA region, right? On Headstar. So when it exposes, when it pushes a metric to Thanos, what it will do is it will add this specific label, Prometheus equals EMEA/rig. So we know which specific cluster it came from, and this is how we will be able to differentiate between metrics from between clusters.
Yeah, so we want to send all cluster metrics because of user workload monitoring. We'll have metrics for each cluster, and then we can send all those to a central location and then use that as a data source in Grafana so that we can have the same charts that can be applied to the end result would be basically like, let's say you have a Grafana dashboard for monitoring CPU that we've created. We can then just kind of like based on a drop down change that dashboard's source to like a different cluster, but keep the dashboard the same, right? This will allow us to make like very generalized dashboards. And when we onboard a new cluster, we can easily like add that, like enable that dashboard for a separate cluster and do this with all dashboards. So that's what we're also working on right now. So yeah.
Yeah, so if you're not familiar with Grafana, this is what Grafana looks like. It visualizes all of the metrics that are exposed with Prometheus. Grafana queries Prometheus, collects these metrics, visualizes them. Super efficient, looks pretty cool stuff. Grafana is also used as a UI for uh, Loki, so you should be able to use Grafana to query logs. If you wanted to just create a dashboard with metrics and logs, you can combine all of this stuff and mix and match.
Yeah, and all the dashboards he's showing, they are also like the ones that we create, we put them in Git. So same concept, and then
Oh, yeah.
they can be shared out.